In a previous video, we developed a test which helps us determine whether a particular force is conservative or non-conservative. Right? The way we do this is we take a mass and we send the mass around a closed path, and then we compare the kinetic energy of the mass at the beginning of the motion with the kinetic energy of the mass at the end of the motion. If the kinetic energy at the beginning of the motion and the end of the motion are the same, that suggests to us that we're dealing with a conservative force. On the other hand, if the kinetic energy at the beginning of the motion and the kinetic energy at the end of the motion are different, that tells us we're dealing with a non-conservative force. So in this video, we're going to apply that test to the frictional force. And here's what I'm going to do. I'm going to take the mass at the bottom of the incline, and I'm going to give the mass a push. So what's going to happen is the mass is going to slide up the incline and then hopefully slide back down the incline. And here's the closed path. The mass is going to pass this chalk line on the way up and then pass that chalk line again on the way down. So from passing the chalk line on the way up to passing the chalk line on the way down, that is a closed path. Now, on that closed path, there are two forces acting actually. We have the gravitational force and the frictional force. Now, we've already seen that the gravitational force is conservative, so the total work done by gravity on the closed path will be 0. We don't have to worry about that. So what we do is we're going to observe the motion. We're going to compare the initial kinetic energy as the mass passes on the way up, and the final kinetic energy as the mass passes on the way down. So any change in kinetic energy between that initial kinetic energy and the final kinetic energy would have to be due to friction. Okay, so let's do the experiment. Okay, one more time. Okay, so I hope you could see that the kinetic energy of the mass as it passed the line on the way up and the kinetic energy of the mass as it passed the line on the way down were different. The mass had more kinetic energy passing the line on the way up, less kinetic energy passing the line on the way down. So that's a difference in kinetic energy. That tells us that friction did a total work not equal to 0 as the mass moved around the closed path. That means friction is a non-conservative force.